In this video, we're going to be talking more about counting problems and one of my favorite counting problem strategies. So let's get started. So I'm going to come up with a problem first. That's our first step, which let's say we want to come up with 3-letter words in which we have to have a B. And the alphabet we're using is standard 26 letter A to Z alphabet. So your standard 26 letter alphabet. So here what we're going to do is we can repeat as much as we want. So we can have letters like A, and etc. So we're going to count the number of ways we can do this efficiently. So we need one B or more in each word. So the way I'm going to do this, I'm not going to count A, B. That's going to take too long. What I'm going to do is, we have a restriction here, and we're going to place that restriction in. Whenever we have a restriction, we place it in. We plug in a restriction. So we have a restriction of a B. Now, I'm going to start off just by listing how many words we have with one B, right? If we have one B. I'm going to list the number of ways we have one B. And this B can be in, it can be here, it can be here, and /or it can be here. So, given this in mind, we are going to be solving this problem. And we're just going to start by counting the number of letters we can form with one B. And we're just going to start with a standard construction in which we have a B in the first letter, and the second letter, that can be anything but a B. So remember, we have 26. It's a 26-letter alphabet. We picked a B. We subtract a 1. We get a 25. So we have 25 letters to choose from. And in the third slot, we can repeat. So we can choose the same exact letter. So this is 25 again. And 25 squared is 625. And we can do the same thing if the B is at the end. Again, B, that just takes up 1. And this is 25, since we subtract off a 1 because we chose a B, so that's 25 letters. Anything but the B, since we're only counting one B for now. That's going to make it a little bit easier. We have 25 and 25, and we have a B. So, of course, 25, that's just 25 squared, and 25 squared is 625. And there's only one last configuration in which we can do a B in the middle. That's again a 25, 25. This is just a 1, so it's 25 squared, 625. And then to find the total, we just do 625 times 3 to get so we're on a 5, 7, 8, yeah. Alright, so our final answer, not a final answer, but the answer for one B letter words is 1,857. So we obviously have more letters, and we can have 2 B's, we can have 3 B's. And obviously we're not going to sit here and keep counting those like this. That's not efficient. And now I'm going to show one of my favorite counting problem strategies, and that's by drawing a diagram or by using some basic geometry. So by using some basic geometry, we're going to solve the problem. So and we're going to keep our information there so that we have an idea. So I'm going to draw a rectangle. That's our first step. And within this rectangle, we're going to draw a diagram. and I'm just going to record my results in the table. And this is one of my favorite techniques when it comes to counting. We have a diagram. We know that this is just 1,857. And the good thing about this problem is once we figure out a pattern, we can just keep going. So let's move on to 2 B's. So here we're going to have a B in 2 slots instead of a B in just 1 slot. And the way I'm going to do this is the same way. So first we can have a B here, and then any other letter here. And this any other letter can be anything but a B, since we're only counting 2 B's. We're counting this section right here. So this is just 25. And of course, another configuration can easily be counted. We can have a B and a B at the end. Again, 1 times 1, that's 1. We don't need to worry about that. Again, this can be anything but a B, 25. And then the other configuration, again, we don't even need to draw this entire thing. We know that in our head, it's going to be another 25. Since we have 1 slot open that can't be a B, that's just 25. So if we get a little more organized, what we can also do is we can record our computations in the table. So that's going to be pretty useful. So over here, we know we can have 25 plus 25, 25, and 25 times 3 is 75. And I can do the same thing up here as well. Which if you remember, we had 625 times 3. And actually here we can also use multiplication, since it's going to be a bit easier. Alright. So there we go. Much more organized. And then we have 3 B's. Last one. And with the 3 B's, well, that's just one configuration, since there's only 1 letter of such, so it's just 1. And now we can add these up. That's what we do. Define number of configurations. 75. Add a 1. So we're gonna have 11. Yeah, alright. So our grand total is 1,951. So as we can see, this table is much quicker at organizing our ways. And to make this even better, we can add another row to the table by just row, and it's going to be a total, which we just add them up. We can also use this row as sort of an addition helper, so we can put a 1 here and then just add. So as you can see, this table thing is extremely helpful in counting problems, especially when we need to break some cases up. So that's like, I'd say counting with geometry, I guess. Hopefully this video helped. And yeah, that is one of my favorite counting problem solving techniques.